Good evening, sir.
Very good evening. How are you?
Sir, I'm fine.
Okay, so now there is only one student left.
Yes, sir. I'm calling him, sir.
Okay, sure.
Oh, Sankalp is not joining.
I don't know.
Yeah,
Sir,
so
I think
shall we
everyone
start?
came, sir.
Yeah, so
Yes,
shall
sir.
we start the class?
Yes, sir.
Okay, all right. So first of all, let me share the screen with you.
So are we gonna do a revision?
No.
Sir?
Yes, is this screen visible to all of you?
Yes, sir.
Yeah, yes, sir.
So are we gonna do a revision?
No, today we will actually study the radicals and also how to balance chemical equation. So is it screen visible to all of you?
Yes, sir. Yes, sir.
Yes, sir.
So first of all, let's see the radicals. We are having acidic radical and basic radical, acid radical and basic radical, right?
Yes, sir.
Yeah.
Just if I will write any positive, this is my radical. Similarly, if I will write Cl negative, it's also my radical. Similarly, sulfate ion, it's also a radical. If I will write OH negative, so all these are your radicals. But radicals are of two types. One type of radical
Single
that's known as
atom.
acid radical, right? Acidic radical.
Yes, sir.
Okay, so
Sir,
what are
so what you
acidic?
teach? Sir, what you're teaching today is also there in the test, right?
Today we will also study about how to balance chemical equations.
No, sir. He's,
No,
he's
sir.
asking if what we study today will be the test tomorrow.
Okay, in the test you will be asked the topics which you have studied earlier.
Not today's.
So today's not today's.
Then
Sir, not today's topics. Today's topics won't be there in the test.
it will be also in the test. So this will be important.
Oh, okay, sir.
Okay.
Okay, so acidic radicals. So that means these are those radicals which actually come from acid, right?
Yes, sir.
Yes, sir.
Acidic part. That means they are actually those radicals which have negative charge. So they have negative charge. So have negative charge. So they have negative charge. So if I will write for example, if I will write Cl negative, if I will write F negative, if I will write SO4 negative, these are all your acid radicals. So that means negatively charged ions, they are your acid radicals. Got it?
So, yes, so what's the
Yes, sir.
definition of radicals? Actual definition.
Okay, I will tell you. So let you write down this. This will be very important.
Yes.
A radical is any charged species. It can be negatively charged or it can be positively charged. Is this screen visible to all of you?
Yes, sir. So, what did you
Yeah,
say?
exactly. So radical is actually one of the negatively charged part from salt. For example, if you have salt like NaCl, so this is your compound NaCl, salt. But here, if you will separate it, if you will ionize it, it
Sodium.
will give you, yeah, exactly, any positive and Cl negative. So these are your radicals. So actually these radicals, where they come from, they actually come from either acid or they come from base. For example, if you are having the acid hydrochloric acid, HCl, so can you ionize this HCl? Exactly, it will give you
H,
positive,
H2,
So
OH
H
H
plus,
plus and Cl2
Cl
minus.
minus.
Oh,
H
sorry.
positive and Cl negative. Yeah, H positive and Cl negative, they are your radicals. So radicals, they are
How
actually
is
your
Cl2
charged
minus?
species.
It's Cl1 minus, right?
It will
Yeah,
be
it is
Cl
Cl.
minus because charge should be get balanced.
Yes, sir.
So radicals will be balanced, by which in one it will be positive and another it will be negative. That's all.
Exactly, it is very simple. One is H positive, that means +1 charge, and another will be -1.
Some
Okay,
stuff
sir.
like there is also non-metal plus non-metal.
Yes. So
Those
have
are not
you,
radicals.
which one?
It's a non-metal, non-metal. Any formula
Non.
with non-metal. That's not possible.
Okay, for example, if it is your this ammonia, it is not a radical at all, because actually here both, it is not a charge, it's a covalent molecule. It should be ionic, then there will be radicals possible.
This is an ion.
So no radical for this ammonia. So if I will just write the salt of this ammonia, that is actually ammonium chloride, then this is your here the radical. So the radical is here NH4 positive, that is your basic radical, and similarly Cl negative, it is your acidic radical, right?
Yes, yes.
Yes, sir.
Yeah.
So
So
can you go to
so
the previous?
previous slide, okay, I will show it. So this is your previous slide.
Yes. Yes.
You can write up. So have you noted down?
It's almost.
Yes, sir.
Yes, sir. Noted down, sir.
Okay, so let's see now the basic radicals. So basic radicals will be those which are actually coming from the base.
Yes, sir.
Coming from base, so that means they will be your positively charged. So have positive charge, right? Have positive charge. So acidic radical, they have negative charge, and these basic radicals will have, definitely they will have the positive charge. So that means all these metal ions, that is any positive, Cu2 positive, let's say magnesium divalent positive, aluminum trivalent positive, all these are your basic radicals. They are actually coming from the base. You are having the calcium 2 positive, you are having the potassium K positive, all these are your basic radicals. They are actually coming from the base. I will give you the example. For example, you are having NaOH, sodium hydroxide, so it is a base.
Potassium
Yeah,
hydroxide, calcium.
exactly, potassium hydroxide, it is also a base, isn't it?
Yes.
Exactly, similarly,
CaOH twice.
exactly, calcium hydroxide, that is CaOH whole twice. So all these are your bases, and the ions which you will get from these, they are your basic radicals. Just you will get here Na positive and OH negative. OH negative will be your acidic radical,
Yes,
and
I
Na
am.
positive will be
Oh, it's a
basic. Yeah,
radical, sir.
yeah, exactly. So K positive and OH negative, so these are your radicals. Similarly here it will be Ca2
So
positive.
OH is a radical.
Yeah, exactly, OH is the radical.
Okay.
OH negative, it should be charged species.
Yes.
So
So
have you
then how
noted down?
come ammonia or ammonium not become a radical?
Yeah, ammonia is not a radical because there is no charge on this, but this NH4, it is a radical because it is in the form of
Oh,
NH4 positive.
oh, okay.
Got
Yes,
it
sir.
now?
Now I understand. Yes.
Yes, sir.
Okay, great then. So shall we move ahead? Have you noted down?
Yes.
Yes. Sir, can you
Yes.
just explain basic radical once more? I don't get it.
Okay, sure, no problem. So basic radical, I told that these are those ions which are having positive charge. Just we are having this any positive. So this is definitely
Yes,
your
sir.
basic radical. Cu divalent positive. So all positively charged species, they are your
Oh,
basic radicals. They are actually
okay,
coming
sir.
from the, yeah, they are coming from the base.
Oh,
Just we are having NaOH, it is a base. KOH, potassium hydroxide, it is a base. Calcium hydroxide, it is also a base. So definitely
yes,
these
sir.
are your basic radicals. Got it
Yes.
now?
Yes, sir.
Yeah, exactly. That means these are actually coming from the basic part, from the base. And
So
acidic,
only bases can be basic radical. Only base.
yeah, acidic radical, they will just come from the acid. And basic radicals will come from the base.
Okay.
You can simply differentiate these on the basis of the charge. For example, if there is positive charge, you will get that it is a basic radical. If there is negative charge, that is your acidic radical.
Okay.
For example, if I will tell you here that you just tell me, if I am writing here CO3 2 negative, you have to tell whether it is acidic radical or basic radical.
Acidic.
It's
What do
acidic,
you think?
sir.
Exactly. You have to just see that if there is negative charge, so definitely it is your acidic radical,
Can
isn't
you
it?
hear me? Can you hear me?
Yeah, this is known as carbonate ion. I will name it. It is known as carbonate ion.
So can you hear me, sir?
Okay, sir.
Carbonate ion.
We can hear you. We can hear you.
Okay. That's it.
Okay, can you hear me all?
Yes,
I
sir.
can hear.
Okay, is voice clearly audible to all of you?
Yes, sir.
Yes, sir.
Okay, fine. So this is your carbonate ion. It is definitely your acidic radical. Now, similarly, if I'm just saying that, let's say I'm having this H positive. So what do you think what it is?
So it's a basic radical, sir.
Yeah, it has positive charge. So similarly, if I'm having, let's say magnesium is there, 2 positive. So definitely it is also your basic radical, isn't it?
Hydrogen has positive charge.
Similarly, if I'm having NH4 positive, so this will also come in the basic radical. Correct?
Yes, sir.
Yes, sir.
Yes. So then can you now tell me, let's move ahead and let's study what is a chemical equation. So can you tell me what is a chemical equation?
When two or more reactants combine to form a product.
Exactly. So I will write it here that chemical equation. So it is actually the shorthand representation of a chemical reaction. You will note down this, that it is the shorthand representation, shorthand
Presentation of equation
of a
of a
chemical
reaction.
reaction. Exactly. It is the shorthand representation of a chemical reaction. So what is a chemical reaction?
Two or more reactions forming a product.
Yeah, exactly. When two or more than two reactants they combine and they form a new product which has new properties. So definitely that is your chemical reaction. So now how to write this chemical equation in a very short way, short manner. So that is known as the chemical
Uh,
equation. So it is the shorthand
yes.
That's
representation of a
chemical
chemical
equation.
reaction. And how you can write this in terms of symbols and formulas,
Symbol.
right?
Yes.
In terms of symbols and formulas of various reactants and products, isn't it?
Yes, sir.
Of various
Re-
elements.
various It is the shorthand representation of a chemical reaction in terms of symbols and formulas of various reactants and products. Because in any chemical reaction, there will be definitely reactants and there will be products. For example, if I have to write a chemical equation, for example, if you say that carbon, it reacts with oxygen, it forms carbon dioxide, then I will just write its chemical equation like this. That is the carbon, its
P
symbol is
plus
P,
Q gives CO2.
plus O2, it gives you, yeah, exactly CO2. This is the chemical equation, how to write chemical equation. So whenever there are more than one reactant, that means if there are two reactants, they are separated by this plus sign. So you have to note down this, you have to remember this, right?
Yes.
And whenever we are now having these carbon and this oxygen, they are my reactants. I will write them as or, and this carbon dioxide, it is my product, right?
Yes, sir.
I will write it by P. So that means if we are having more than one reactant, or if we are having more than one product, so then we will just separate them by plus sign. Got it?
Yes. Yes.
Okay, so let's move to the next slide. So for example, if I will write a chemical equation here, a general chemical equation can be written like this. For example, A, it reacts with B and it forms me product C plus D. So that means here A and B, they are my reactants, isn't it?
C plus D are your products.
Exactly, C and D, they are my products. For example, if
Yes, sir.
magnesium, it reacts with oxygen, if it is burned in excess of air, then it will result in the formation of
Magnesium oxide.
Magnesium.
exactly
Magnesium
MgO.
oxide. MgO.
Exactly, magnesium oxide.
2
Now, similarly, there are a lot of reactions. For example, if iron, it reacts with steam. Steam means water in the form of water vapor, right?
Yes, sir.
Yeah, H2. So then it forms
PO
product
plus H2.
Fe3O4 plus H2. So that means here the products are also two, so they are also separated by plus sign. And also here iron, it reacts with water, so they are your reactants.
Yes.
Yes,
So
sir.
Fe3 is ferric or ferrous, sir?
This is your Fe3O4.
Ferric
It is your
oxide.
exactly the ferric oxide.
Yes.
So on the test, will you tell like find the chemical formula for magnesium plus oxygen?
Exactly, this is your magnesium oxide, that is MgO. Magnesium, it is having two valency, and oxygen is also having the two valency. So that is why the formula will be MgO. Got it? Now, actually, what we have to study here, we have to study how to balance chemical equations. So chemical equations are of two types. One is the balanced chemical equation, another is the unbalanced, right?
According to the law of conservation of mass, no matter.
Yeah, I will just write here. One is the
Created or destroyed.
unbalanced chemical equation, unbalanced. So unbalanced chemical equation is that which atoms are not balanced on both the sides.
Some atom are created out of nowhere.
For example, as I told you that magnesium, it reacts with oxygen, isn't it?
Yes, sir.
And it forms you the magnesium oxide. So can you tell me, is it balanced or not?
No, sir. 2 Mg plus O2 gives 2 MgO. That's balance.
See, exactly. There are two oxygen atoms on the reactant side, and there is one oxygen atom on the product side. So that means it's
Sorry,
unbalanced,
sir.
right?
My internet got disconnected. I left.
No problem. Have you now joined it again? Is it now stable?
Yes, sir. Now it's stable.
Okay. So now can you tell me, if I will just write here, let's say I'm having calcium. It reacts with water. So it will form the calcium hydroxide. So is it a balanced chemical equation or not? What do you think?
Sir, it's not.
It's not.
Yeah, it is unbalanced because
Yes,
we are
sir.
here having one oxygen atom, but here we are having two oxygen atoms, right?
Yes.
Sir.
Yeah, you have to understand that it is OH whole twice. OH whole twice means there are two oxygen atoms, right?
H2O should also be used.
Yeah, exactly.
In
So
the
that means
reactant
these
side
reactions.
OS now.
Yeah, okay. Now, can you tell me, is this reaction balanced or unbalanced? It is magnesium, it reacts with hydrochloric acid. It forms me magnesium chloride, that is
Magnesium
M.
chloride plus hydrogen. No, plus
No,
hydrogen.
plus.
Plus hydrogen. Chloride is not balanced.
So chlorine is not
Also not
balanced.
balancing.
Hydrogen
A
also
2
not
before
balanced.
HCl. You have
Yeah,
to
so
put it
that
2 before HCl.
yeah, so that means these reactions, they are your unbalanced reaction.
Chemical.
Exactly. Okay, now let's see.
Just to find the
You can
chemical
just
formula,
balance these.
does that mean we always need to balance and write? Like for the
Yes.
previous one, you told magnesium plus oxygen gives you magnesium oxide. But
We
when
will
you
learn.
wrote magnesium oxide,
Just,
you didn't.
just have patience. We will learn how to balance these chemical equations. I will tell you how to balance and why we balance. So first, let's see what are balanced chemical equations.
So that we can just balance the previous equation.
We will learn this how to balance. So balanced chemical equation. So balanced chemical equation is that in which the number of atoms of all the reactants, they are equal to the number of atoms on the product side, right? Exactly. For example, if I am just writing, let's say,
Magnesium oxide itself. Magnesium plus oxygen.
okay, if I am writing like this, I am having magnesium, it reacts with hydrogen, and it forms the magnesium hydroxide. That is Mg, magnesium hydride. That's MgH2.
Oh, okay. So how is it hydroxide? So there is only hydrogen, sir.
Yeah, it is not oxygen, it is now hydrogen. It is magnesium hydride. I will write the name. It is the magnesium hydride.
So it's already balanced. Oh, okay.
Yeah, exactly. It is
balanced.
balanced. So that is why I have written that it is a balanced chemical equation. I'm just giving the example of balanced chemical equation. For example, carbon, it reacts with oxygen. It forms the carbon dioxide. So is it balanced or not?
Yes, sir.
Yeah, it is balanced, isn't it?
Yes, sir.
Exactly. So if I will write here zinc, it reacts with sulfuric acid, H2SO4. So now it forms zinc sulfate, that is ZnSO4, and it forms also the hydrogen gas. So can you tell me, is it balanced or not?
Sir, it is balanced, sir.
Exactly. Now there is a very important question for you, that actually whenever we have balanced equation, then we have to do nothing with it. But if we are having unbalanced chemical equation, then we have to balance it. So can you tell me why we balance chemical equations?
Because mass
Sir, it's
cannot
because
be
of the
created
rule
or
of
destroyed.
no, sir.
Yeah,
Yeah, no.
because of which,
It
It's
is
because of the law of
exactly, because
reaction mass. I forgot. I
of
forgot
law
the
of
law name,
conservation.
sir. I
Yeah,
conservation
okay.
forgot
of
the name of
matter.
the law.
I will write.
Conservation of
In order to follow law of conservation of mass, right?
yes, sir.
So you will write that in order to follow law of conservation of mass,
Cannot be destroyed.
so can you tell me what it this last states? You have studied this in class 9. So law of conservation of mass, it states that mass can either be created nor be destroyed,
Or
isn't it?
destroyed.
So,
Yes, sir.
Yeah. So that means you will just remember here that total mass of reactant is always equal to the total mass of products, right?
Yes, sir.
So law of conservation of mass, what it states, I will write it here. It states that total mass of reactants, it is always equal to the total mass of products, right?
yes.
Total mass of product. So that is why whenever we have unbalanced chemical equation, then the total mass of reactants, it will not be equal to the total mass of product. So that is why we are balancing it in order to follow this law of conservation of mass, right?
Yes.
Yes, so you will remember that in order to follow law of conservation of mass, we are balancing this chemical equation, correct?
Yes, sir.
Yeah, so then let's learn how to balance chemical equations, right? So I'll write it here that how to balance chemical equations. So can you tell me how to balance chemical equations?
So just
I
the
hope that
number
you
of
have learned.
Yes, sir.
yes,
So you have to
yes, sir.
count the number of each element in both sides
Add
and then multiply the elements in both sides so that they both equalize.
Yeah, so that method actually, you are actually equalizing by multiplying either by 1, 2, 3, 4, by any number. So this method is actually known as hit and trial method, right?
Oh, we didn't learn that, sir.
Okay. You just write it down that it is known as hit and trial method. Hit and trial means you just hit and you just try either by 2, either by 3, either by 4, unless and until it gets balanced, right?
Yes, sir.
Yeah. So for example, let's start a very simple chemical equation. For example, if I will
Magnesium
write
oxide.
magnesium, yeah, exactly. It reacts with oxygen, it forms me the magnesium oxide. So the magnesium oxide, its correct formula is MgO. Now you have to balance this. So
Sir,
how to balance?
2
Sir,
mg
2
plus
mg plus
O2
O2
gives
gives
2
2 MgO.
But okay, let's start with the oxygen. See, magnesium is one atom here on the reactant side, and on the product it is also one. So nothing to do. First of all, let's see now oxygen. Oxygen here it is 2 and here it is 1. So what I will do, shall I multiply 2 here?
oxygen with 2. Yes, sir.
I have multiplied oxygen with 2. Is it correct or incorrect?
Correct, sir. Then you have to multiply magnesium also with 2.
No, it is incorrect. It is incorrect because we have to always multiply 2 on the left side.
Whole
So
thing.
here,
That's what I have to say.
yeah, we have to multiply 2 here. This is very important and I hope you will note down this.
Yes.
So when I have multiplied it by 2, so that means this 2 is multiplied to both magnesium as well as
Yes, sir.
oxygen. So now the magnesium are 2, so I will write here 2.
Yes, sir.
Exactly. So is it now balanced? Yeah,
Yes, sir.
Now,
Yes, sir.
exactly. It is now balanced, correct?
Yes, sir.
Any doubt here?
no, sir.
Yeah, it's very easy and I hope that now you can balance. Okay, then if I will write another equation. For example, if I am having magnesium and it reacts with hydrochloric acid
Mg is
and
magnesium chloride plus hydrogen.
it gives yes, magnesium
MgCl2
chloride
plus
plus
hydrogen.
hydrogen.
H2.
So how to
So,
balance this?
yes.
Mg plus H2HCl gives MgCl2 plus H2. Yes,
Sure,
Exactly.
in front of HCl.
See, we are
multiply
having here
HCl
one
with 2.
hydrogen and here we are having 2 hydrogen. So what I will do, I will multiply this by 2. But
Need to
always
multiply
remember
HCl with 2. That's all.
always
That's all.
remember that we have to multiply this 2 on the
Whole
left
number.
side.
Like whole.
Yeah, it should be whole. Yeah. So then here it's also now 2 hydrogen.
Chlorine.
Chlorine here is 2 and chlorine 2. So it is now balanced.
Magnesium is already balanced. Yes.
Yeah, magnesium is already balanced. Right?
Yes, sir.
Yes, sir.
Any doubt here?
No, sir.
Okay, so then if I will write another equation, can you balance that?
Yes, sir.
Okay, so let's try to balance this one equation. If I will write the equation which I have already written, that is Fe iron, it reacts with water steam.
Fe3O4 gives H2.
And
G plus H2.
Fe4 plus H2. So can you balance this? Can you try?
3Fe.
Yes, sir. 3Fe.
Fe plus
Sir,
4
3Fe plus
H2O gives Fe3O4
no.
plus 4 H2O.
3Fe plus 2H2O.
No, 4O.
Oh, no. Yeah, it's
4
4
4
H2O
H2O plus
gives
Fe3O4
Fe3O4 plus 4H2.
4 H2.
Exactly. This is now correct. This is balanced, right? So is having anybody of you having any doubt here? Is it clear to all of you?
Yes, sir. It's clear.
Clear.
See, okay, I will repeat it again. See, first of all, we were having 3 iron atoms here and here it was 1. So I multiplied it by 3, right?
Yes, sir.
Then we were having 4 oxygen atoms here on the product side. So I multiplied here it by 4. So 4 times water means we are having 4 oxygen atoms. So here also 4. But now hydrogen is 4 twos are 8. So I will multiply it by 4 also. So 4 twos are 8, right? Clear?
Yes, sir.
Okay, so then let's move ahead. So if I will write an equation like this, you have to balance this.
Sir, can you go to the previous slide for a second?
Okay, sure.
Yes, sir. Thank you.
So have you noted down all?
Yes, sir.
Okay, shall I move ahead?
Yes, sir.
Yes, sir.
Okay, so if I will write an equation like this, that magnesium nitride, that is Mg3N2. It reacts with water and it forms magnesium hydroxide, that is MgOH whole twice, and it also gives you ammonia, that is NH3. So can you balance this equation? Can you try?
Yes.
Yes, sir.
Okay, you just try it out.
It is a well, don't tell the answer.
Yeah, all will try on your notebook, then I will ask.
Yes, sir.
So how many marks is the test for tomorrow?
So have you balanced it, any one of you?
Oh, yes, sir. I'm doing it. I'm doing it.
Okay, okay. So have you balanced it now?
So I did it.
Sir,
I did
yes,
it.
sir. Yes, sir.
Okay, tell me.
It's
So
Mg3N2
plus 6H2 O
plus
gives
plus 4H2O gives 3 Mg OH2
OH whole twice
plus
2
2.
NH3.
Yes, sir. That's what I got.
So is it balanced now?
Yes, sir.
Yes, sir.
Exactly, it is now balanced. So what you have to do actually, first of all, you will just take such a molecule, whether it is on the reactant side or product side, which has large number of atoms. For example, this magnesium nitride, it has 5 atoms, 3 that of magnesium and 2 that of nitrogen. So see here, magnesium, we are having 3 atoms. So here it was only 1. So we will multiply it by 3. And then we are having nitrogen 2 here. So we will multiply it by 2 here. And then we are left with oxygen and hydrogen. So here oxygen are 3 twos are 6. So I will multiply it by 6. So then we are having hydrogen 6 twos are 12. So here we are having 3 twos are 6 and 3 twos are 6. So 6 and 6, 12. So it is now balanced, right?
Yes, sir.
Yes.
So any doubt here?
No,
Sir,
sir.
No, sir.
I don't get
Okay.
it. on the reactant side, the
Okay.
total number of how many hydrogens on the reactant on the
On
product
the
side. On the
reactant
product
side, the reactant side, we are having 12 hydrogen atoms. 12. 6 twos are 12. 6 twos are 12.
Yeah, no, on the
Question.
product side, before the
Okay.
reaction, how many hydrogen atoms do we have? Before
Okay,
For
the
you just
reaction, there won't be reactants.
on the product side, see, we are having in ammonia here, we are having 3 twos are 6 hydrogen here, and here also we are having 6. So 6 and 6, that's 12. So 12 on both sides, so it's now balanced.
Okay. Yes, sir.
Are you still having doubt?
No, sir.
Is it clear?
Yes, sir.
Yes, sir.
Exactly. Okay. So if now I will write question like this, that I'm having equation like this. We are having, let's say, potassium. It reacts with water. It forms potassium hydroxide plus hydrogen gas. So can you balance this one?
Yes, sir.
So you just try it out.
Finish, sir.
Yes.
Isn't it? Is it clear?
Yes, sir.
So have you balanced
Yes,
it, any one of you?
Yes, sir. Yes, sir.
Okay,
Me
tell
and
me.
Kogal can. Sir,
Okay, tell me.
2K plus 2H2O gives 2KOH plus H2.
Exactly, it is now balanced, right?
Yeah, that's correct.
Yes.
Because we are having now 2 potassium here and 2 potassium here. We are having 2 to the 4 hydrogen here, and here also 2 and 2 4.
Yes, sir.
And oxygen we are here having 2 on the reactant side, and on the product side we are also having 2, right?
Yes, sir.
So I hope that now you can balance chemical equations, right?
Yes, sir.
Yes, sir.
Okay, so if I will write a chemical equation like this, that nitrogen, it reacts with hydrogen and it forms ammonia. So can you balance this one?
Yes, sir.
Okay, tell me.
Ammonium.
Done, sir.
Oh, yeah.
Sir,
is
it's
ammonia.
N2.
Done, sir. Done.
Sir, it's N2
Yeah.
plus 3H2
3H2.
gives 2 NH3.
Exactly, it is
Yes,
now
sir.
balanced.
Yes, I also got.
Sir, can you show the previous slide for a second?
Okay, sure.
Thank you.
Most welcome. So now can you balance this one? If I will write NH3, it reacts with oxygen and it forms nitric oxide plus water. So will you try this one equation? This is very important.
Yes, sir.
Yes.
The oxygen, I don't get it.
How to try it out?
So, like on the product side,
Write it on
the
paper and
oxygen
do
is
it.
5. Yeah, I'm doing it like oxygen is 5, but in the reactant side, how will I get 5?
We have to multiply it with 5.
Bruh, it's 2 da.
You just try it out. Then if you are not able to balance this, then I will try. I will balance it.
Yes, sir. One
I
second.
don't think.
No, it's possible. I'll do it.
It is not like that it will not get balanced. It will get balanced, but it will take you time, but you have to try it out.
Sir, is it? 1 second, sir. Just write it down.
Hey, tell it, I can't do it. I'm not getting this oxygen.
1 second. I'll write it down. I'll check if it's balancing and then I'll tell.
Sure. So are you able to balance this, or shall I show you?
I don't
Sir,
get the
I don't know,
oxygen.
sir.
Yeah, the
Okay, no
oxygen
problem.
is-
No problem. Just to focus, I will explain each and everything. See, we are having oxygen here, 2 atoms, and here we are also having 2. So it's already balanced, right? But
Yes,
when we
yes.
just talk of hydrogen, we are here having 3, and here it is 2. So if I will multiply it by 2, so it will become 4, but here it is also my 3 only. So it's still not getting balanced. So what I will do, I will just write twice ammonia.
Sir,
3, that's it, sir. 3 H.
is it 2? So is it 2 NH3 plus 6 O2?
Wait. Just focus on. So nitrogen we are having 2, so I will write here 2 now. We are having hydrogen, 3 2s are 6, so I will write here 3 3 2s are 6. But now we are having 5 oxygen atoms on the product side, 3 and 2 5. But here we are having 2, so if I will multiply it by 2, so it will become 4. If I will multiply it by 3, it will become 6. So then how to
Yes,
balance
sir.
this? I will just
I
write
also couldn't get.
so 5 2s are 10, right?
Yes, sir.
Yes, sir.
So 10 upon 2, so that is 5. So 5 upon 2, it will now get balanced.
Wait, what?
You can do it like that.
Yeah,
Sir,
but this
I-
is not okay. I will tell you, this is not very much appropriate. We have to remove this fraction. But first of all, have you understood that how to do this? That it is
What
5
did you
2s
do
are.
this now, sir?
Okay, I will tell you how to remove this fraction. Now, what you have to do after that, you have to multiply the whole equation by 2. You have to multiply the whole equation by 2. So when you will multiply by 2, so that means 2 2s are 4. So you will write 4 times ammonia. And then 2 and 2, it will get cancelled. So it will be now 5 times O2. And then it will be 2 2s
Sir,
are
got it,
4.
sir. It's
Sir, why don't you
4NH3 plus
multiply 5, sir?
5O2 gives 4NO plus 6H2O.
Exactly.
Why don't
So
you
now,
multiply the 5,
Yay.
sir?
no, we have to remove this fraction. So that's why I will multiply it by 2, not by 5.
The entire thing.
Yeah, entire
No.
thing, exactly.
Sir, before you multiply itself, the 2 will be cancelled, right, sir?
Exactly. 2 and 2, it will get cancelled.
No, that 2 and 2. I thought the 2 there and the O2. So that 2.
No, it will get multiplied. We have to multiply this 2 to the whole equation. So that
Okay,
is 2 to
okay.
the. Okay, so is it now balanced? Can you check it again? Is it now
Yes.
balanced?
Yes, sir, it is.
You can check it out. Hydrogen we are having 4, so here it's also 4. Hydrogen 4 3s are 12, so it is also 6 2s are 12. Oxygen we are having 5 2s are 10, so here it is 4 and here it is 6, that is 10. So it is balanced now, right?
How am I supposed to
Yes,
know
sir.
about this fraction, sir?
So whenever there is fraction, you have to remove that fraction by multiplying the whole equation by 2. I will give you the next example. You just copy this first
So,
one.
1 second, sir. 1 second.
Okay. This will be very important because sometimes such reactions are given in which you are actually getting fraction, but you have to balance that. So I hope now you can balance. You have to just simply multiply the whole equation by 2 so that the fraction will get removed. Clear now? Is it clear now? Is my voice audible to all of you?
Yes, it's audible, sir. It's clear, sir.
Okay, so let me give next example. So if it is like this, it is methane, it reacts with oxygen, it forms the carbon dioxide and water. Can you balance this? It is easy.
1 second, so 1 second. Please
Okay.
don't tell the answer. 2 seconds, you can tell the answer.
Yes, sir. Even I can't do it.
You can't do it now.
It is very easy. I hope all of you should be
So
able
1
to
second.
do. Okay.
Oh yes, sir. It is
Sir, finish, sir. I only
Yes.
put one
Okay.
number, sir.
yeah.
2H2O,
Okay.
sir. That's it, sir.
2H2O. Okay.
That's it.
2H2O. Correct?
Yeah.
Oh,
That is oxygen we have
That's it.
balance.
oxygen
Yes,
is
it's
wrong.
already balanced.
No.
It's
There's
correct.
have-
two oxygen on this.
The CO2, sir. 2 plus 2. 4.
Exactly.
Oh, yeah. Okay. Sir.
So is it now balanced? Right.
Yes, sir. Now it's balanced.
Yes, sir.
Okay. Now if I will write C2H6
What?
plus O2.
So I just ethane.
Yeah, exactly. It is your ethane. So can you balance this one?
Yes.
Okay, try.
So why would it always give carbon dioxide and all?
Yeah,
hydrogen,
because
water, sir?
it's a combustion reaction. On combustion, you always get carbon dioxide and water.
Oh, okay.
Combustion reaction.
So finish, sir.
Tell me.
Sir, it is C2H6
4H2O2
plus 4.
4O2. Okay.
and 2
And then it's 2, sir. That's it, sir.
4H2O.
Sorry,
4H2O.
4. Yeah.
4H2O.
Sorry, sir.
Hydro.
Hydrogen is not balanced.
Yes,
So
sir.
how to
4H2O,
balance?
sir. 4H2O.
So is it balanced? No, it's not
Yes, sir.
balanced.
No,
No,
sir.
sir. It's balanced.
No, it's not balanced.
Balanced. So 6, sir. It's 6 and then 2 plus this 4 plus 4 is equal to 8.
So it's
4
balanced,
and 2
sir.
is
Hydrogen
It's
is
balanced.
not balanced. O2s are 8 hydrogen here on the product side, but here
Oh,
we're having
three.
only.
Oh, okay, 3. So 3 plus 4, 7. We can't balance it, so it's
Oh, you have to use that
Sir.
fractions.
5/3.
So if I will write 3 here,
Yes, sir. Sir, it's
so they,
5/3, sir.
exactly. There is also coming the fraction, so that's why it is similar to the earlier one.
So 5/3, sir.
And so what you will do now here, we are having 7 oxygen atoms. So you will write 7/2, right?
Oh, okay. So whatever number is on the product side, you have to divide it by 2.
See,
And
actually,
now
see,
multiply it out.
first tell me how many oxygen atoms are on the product side.
So 7.
Exactly. There are 7 oxygen atoms on the product side. So that is why I will multiply it by 7. So 7 twos are 14. 14 upon 2, that is 7. So it is now balanced. But we have to remove the fraction. So how I will remove the
Multiply
fraction?
everything by 2.
Multiply the whole with 2.
Exactly.
2C2H6.
2
Multiply the
C2H6 plus 7O2. No, wait.
Yes, plus
7O2
7O2 gives
gives
4CO2 plus 6H2O.
6H2O.
Yeah, so you have to multiply the whole equation by 2. So what will be the now final
Yes.
equation? Twice
Yes.
C2H6 plus 7O2.
Gives 4CO2 plus 6H2O.
Sir,
Yeah, tell me.
sir, I didn't get it. How did you get 9/2?
It is not
Right.
it is not
7.
9/2. It is 7/2. It is 7/2.
How did you get 7/2?
Because 7 twos are 14. 14 upon 2, that is 7.
Okay.
Got it now?
Yes, sir.
So with the help of this, we have completed this chapter, that is the language of chemistry. And I hope that you will revise each and everything.
Yes, sir.
Clear? Yeah. Okay, so our
Yes, sir.
today's class has finished. Now you are having the physics class right now. Physics teacher is waiting for you. So wish you all the very best. Have a nice day ahead.
Thank you, sir.
Thank you,
Thank you,
sir.
sir. Bye, sir.
Sir,
Most welcome. Bye.
sir,
Yeah, tell me.
sir, sir, before we leave, can you tell me the valency of one sec,
Valency of what?
one sec.
Tell me in the fast.
Yeah, sir. It's,
Valency of what?
sir, the valency of one, yeah, the valency of copper in
Hmm.
copper chloride.
That is CuCl2, right?
Cu2Cl2.
In CuCl2, valency of copper it will be 2, but if it is Cu2Cl2, then the valency of copper will be 1. Got it now?
Cu2Cl2, the
Exactly.
valency will be
Valency will be 1 here, and in CuCl2, valency will be 2.
it be one, sir, because
In CuCl2, valency will be 2, and in Cu2Cl2, valency will be 1.
yes, sir. Thank you.
Most welcome. Okay, have a nice day ahead.